All right. Well, welcome back from the break, everybody. I hope you enjoyed this morning's sessions. And welcome to the second half of AuggieCon 24. I am very excited as a Revit enthusiast to be announcing our next presenter, Brian Mackey. He comes from us. Forgot where you live, Brian. I
I'm in,
apologize.
I'm in Denver, but
You're in Denver.
currently in North Carolina.
And so, if there are any Revit enthusiasts out there, you actually might know Brian as the Revit geek, and you have spent over 30 years in the AEC industry. That's a lot of time. And if you weren't here in the earlier conversation, he was kind of going over some of his history. For more than 20 years, you have been in Revit and BIM. So that's quite impressive. And nearly a decade working with architects and engineers. I apologize. So, Brian started BIM Consulting in 2011 to focus on high level training and mentoring, and he has clients all over the US and Canada. Brian showcases his love of talking and about BIM knowledge um, on his, sorry, on his podcast, not podcast, webinar series Revit Radio that he hosts monthly. And this has been going on for a few years, has it not, Brian?
About 15 years.
15. Oh, okay, that's a few years. Brian is a regular speaker at many conferences, and thank you for joining us at AuggieCon, and including Autodesk University, AIA, and Built, where he has been awarded the top speaker several times. Not surprised. So today he comes to present to us how to ensure Revit family stability, which is a very important topic when you're talking about Revit and families. They are not the same thing. Revit and Revit families. This session will discuss the essentials of family creation, along with tips to gain a deeper understanding of the nuances of making families stable. Understanding this information will result in more stable families, keeping them from breaking during an upgrade or having instability issues. This session will likely share a tip or procedure that has been unknowingly crashing your families for years. Even the most experienced family creators have a family or two that have used crazy workarounds. Knowing this information may prevented a few of those workarounds. Sorry, I was trying to think of another word there. But Brian, the floor is yours, and yeah.
So just got to do one shameless plug every month. And as Christina pointed out before I started, it'll be in 2 weeks, actually, a little week and a half. First Tuesday of every month, I answer everybody's questions on my webcast for a month called Revit Radio. So if you guys are interested, that's the QR code. The other thing I always say is, if you have questions, ask those questions along the way. I'm pretty good at keeping track of questions in the Q&A pod. As long as you put them in the Q&A pod, if you put them in the chat, I'm probably going to be pretty much ignoring the chat as I go through. So that's the session. So everybody knows about families and everybody knows we jump into families. When I always talk about family stability, one of the big things for me when I get in there, we all heard about reference planes, right? We need to do this stuff. We need to use reference planes to create this. So, but a lot of times, and one of the things I see that's most often overlooked are some of the nuances even of just simple reference planes. So whenever you select a reference plane in Revit, we've got this value over here called is reference. And I don't know if a lot of people know what happens with those reference planes when you get into there. So if you select a reference plane in the any template, by default, it's got two reference planes, possibly three if it's a 3D family, one usually equal to the level space. When you start looking at this, there's this is reference value. And this is one of the first things that you can do to start making your family stable, as well as usable for your users that are going to be using this. So there's always these named reference planes. You've got center, left, right, front, back, etc. Those types of names. Revit has pre-built rules into those what's happening. So if you dimension it and your dimension string is set up to have a center line dimension, it's not magic and Revit is automatically coming in to say, oh, look, there's a center of this geometry. It's because you're dimensioning to the center of that reference plane. The same thing becomes true for left, right, front, back, etc. So when we come in here and we start looking at like a reference plane, we look inside of here. If I come in here and I'm going to go in and just grab a quick door real quick in a family, if I place a door in one of these walls and we start looking at those temporary dimensions that come up, these temporary dimensions aren't magic. These are actually snapping to those reference planes, right? So if I edit my door family and I take this door family and I'm going to break this, if I look at this door family and I come into the floor plan and I decide to take this reference plane that's on the right, that is determined to be the is reference right, and I change this from right to left, And then I'm going to come over here to this reference plane, which will now say not a reference. I'm going to change that to be a right reference plane. If I go ahead and load this back into my project, my temporary dimensions are actually going to go wonky, right? So when I select this now, oops, I meant to say yes to that. I was talking. So when I actually go back in here and select this door after I say yes, overwrite the door that's in there, what ends up happening inside of here is this dimensions, those temporary dimensions are actually snapping to the right and the left reference plane inside of there. So now notice my dimensions are backward. They're crisscrossed. So when you start coming there and doing this, there are predetermined rules on what the right reference plane does, what the left does, what the front does, what the back does. And by not following those standards, you can start to break what's going on inside of your project. So again, if I come back to just a simple family, when you're looking at this as reference, paying attention to what's going on with those name references and putting those where they should be. The way I always like to tell people when I'm creating a family, it's kind of like when you're in a plan view, it's like being on stage. Like this would be right stage, this would be the left stage, this would be the front of the stage, this would be the back of the stage. And knowing that becomes very critical, especially for those structural engineers in the firm. If you start with the structural framing template and it says like, oh, gee, this is called the center front back reference plane. I thought that was crazy because beams are drawn this way. I'm like, no, that should be the center left right. I changed the value of that in one of my families early on and realized the opening by face tool did not work on my structural members simply because I changed this from center front back to center left right. So understanding there is references and there's rules for those and things that happen, understanding that becomes one of the critical things. So whenever I'm in a family drawing, if I'm drawing like a reference plane over here and a reference plane over here, I'm going to come back and be like, yeah, the one on the right side in plan should come down here and be my right reference. The one on the left side of the plan should be my left. You're also going to notice that one of those options you get when you're looking at a reference plane is then strong, weak, or not, right? The default templates from Autodesk, when you go create a reference plane, by default, it comes in here having it as not a reference, or excuse me, a weak reference. And we've all been on a project where you go into a project, you try to dimension to something or use the align command, and it snaps to 1,500 different reference planes, right? You'll notice that in like my families, I'm very critical about going in and saying, no, this is not a reference. This is not a reference. And what that means is when this reference plane is loaded into a project, how is the reference going to be? And so when I load that into a project, it's going to come up as not a reference. I can't dimension to it. I can't align to it. I'm not going to get all of those crazy things. So that's kind of one of the big things for me is paying attention to that. There's also then the capability to come in and say, okay, there's a strong or a weak reference. In way older versions of Revit, there was a big difference between strong and weak. You would only get instance-based shape handles, like if you had instance-based parameter, if it was set to be a strong, if it was weak, you didn't get those. That broke probably a decade ago, and now the only difference between strong and weak is if they're on top of each other, Revit is going to find that strong reference plane right away. Or if you're trying to place a family like a freestanding family, it will snap to strong and named reference planes. It won't snap to weak reference planes. It's like if you're trying to place a piece of casework in there or an HVAC unit, it'll snap to any strong or named reference planes like next to the wall or the other object, but it doesn't snap to those weak reference planes. So understanding that becomes critical as well. So one of the other fun things about reference planes, understand besides those two things, is also the fact that there's directionality inside of there. So when I talk about directionality, if I were to come in here and I'm going to give this a name, I'm going to call this one the right reference plane. And I'm going to go to that right elevation and I'm going to go create an extrusion where I use that extrusion as my work plane. Now for me, I will always name my reference planes, not only because it keeps me organized in the family, because if it has a name, then I can use that as a work plane. So I'm just going to come in here and I'm going to go do an extrusion. I'm going to draw a rectangular extrusion, nothing fancy on here. And I'm going to finish this. When I go back to the floor plan to look at this, you're going to notice that that extrusion from that work plane went to the positive direction, right? This extrusion has a positive 12 inches. However, if I had drawn that reference plane the other direction, it's going to go the opposite way. Again, still has a positive value on that extrusion, but it's just letting you know there is a positive and a negative direction on these work planes. Same thing is going to be actually true for sketch lines, but right now we're talking reference planes inside of here. So the reason why I bring this up for family stability as well is when we start getting in here and looking at these types of families, depending on how the work plane was set up and or depending on how the sketch was set up on that directionality, you can get different things. So like this is one cube where I said, okay, the work plane is the ground. I drew the sketch planes differently. I drew this all in there. And you can say I put a little clock on there that when I place this clock on there, it's pointing different directions based on either the direction of the work plane, as in the reference plane I set it to, or even the sketch lines with inside of that. So if I like were to come in here and be like, cool, I want to go ahead and create this new faucet. I'm just going to go, yeah, let's go create a new faucet real quick. If I go create this new faucet family and I host it on that one, notice how it's facing that direction. And then this one, it's facing this direction. And this one, it's facing that direction. You're like, they're all cubes. Why is this rotating around on that cube? Again, it's because of the directionality. So these cubes were all drawn in a floor plan. These cubes were all drawn in an elevation. And again, if I were to go create something on here, you can see that here, this clock is pointing down. This clock is pointing to the right. Again, so depending on which way I drew all those lines, but yet on the side face, the clock is always going to be facing the same direction. So understand, not only do your surfaces have it, but more importantly, your reference planes do as well. So when you get into creating those reference planes, and I had this problem. I had a client, I created toilet partitions for them, and every time they went and added the face-based family for the toilet accessories, they were always mirrored and flipped the wrong way, which is like cool. But then we realized the reason for that is when they were placing it on that family, they weren't actually selecting the host of the solid host. It was getting placed on the reference plane, and the reference plane was drawn backwards, or not backwards, just not the way. So in that family, we literally came in and just drug the reference plane and did this and said, okay, cool, I need the positive side to be out rather than in. And that fixed their family, therefore making it more stable. So understanding all those nuances when you start getting into those reference planes and getting into those things to say, hey, this is what we're looking for. This is what really works for us. That's kind of one of the big things when you start getting inside of there. Okay, I had to move some things around because, oh man, move some things around on my second screen here. Okay, the other thing critical to me on these, and you don't have to, is giving them a name. I did say I give them a name inside of the project or inside of the family because it helps me understand. If I go back to my little door family here, right, I can see the jam. I name all of these. They're set up to be not a reference. You're not going to see that in the project. But what does become nice is when I go back into a project environment, is when I'm using like the align command or the dimension command, it will display that name. So right, when I'm hovering over this the door, it's telling me, hey, that's the door single O. And right now I'm just hovering over that reference. When I get on this one, you're going to say, cool, this one is telling me it's the right reference plane. So it is references the right, and I labeled it the strike. If I come over here to this side, you're going to say, oh, it is references the left, and I labeled it the hinge. So as you start coming through here and looking at this information, you can really get into the cool, those names help you within the project environment. So one of those things I always try to tell people, I absolutely do that. Oops, it looks like my screen paused for a second. Hold on, I was moving things around. I bumped pause share, my bad. So what you'll see, I'll do that again real quick, is if I come in here, hit the align command, you'll see that it is showing me what family is it from, what is the reference after the colons. If this was a work shared project, you'd also see the work set, but then it's also coming there and telling me what name I gave. So I'm always gonna go through and name every single reference plane because it assists me also inside of that project. Okay. Now, the other thing that I always like to show in Revit too is we talked about the reference planes, and if we were going to dimension. And on simple families, this isn't that critical of a deal. But when I was coming in here, if I was going to be saying, cool, I want to go do a dimension on this, and I'm going to have this where the is reference is set to be this insertion point, right? So the other checkbox you get on reference planes is this value here called defines origin. So I know if this is the origin, this is going to be the thing that's locked. This family is going to be growing from there. So when I'm placing my dimensions, I'm going to come in here and select that reference plane first before I go do this equal constraint. And the reason why I'm doing that is because this is the controlling dimension. In old versions of Revit, we used to get these little padlocks letting you know what controlled what. We don't necessarily get those in newer families we create, but it was along the lines of depending on which element you selected for dimensioning first. I selected this middle reference plane, that's controlling, and then I want it from there to move to this one, to move to this one. Then again, just since in Revit I went through and did the right to the left, I want to come back and say, cool, let me grab that right reference plane and then go to the left, same direction, doesn't matter which way I went, but I'm trying to let Revit know in order of operations which way I'm going to go through and start setting this stuff up. So that's kind of the thing for me when I start looking inside of there is I really want to get into the order of operations and making sure that I'm following along with that as I go through and set it up.
That's
So,
fantastic. I don't have any questions yet. I don't know if you're done this section.
nope,
Nope.
yep,
Okay.
I'm still paying attention. So that's kind of those things as well. So when you're dimensioning, pay attention to the order you do it. Same thing, like if I was going to be trying to control the thickness of the reference plane on this family, and I was like, cool, I've now got another reference plane inside of here, and I'm going to put one here, and I wanted to parameterize that, I would not be dimensioning from that reference plane I just created to here, because my length parameter is going to be controlling this one. So I'm going to go from that one to this one. I've literally had clients come to me and say, man, I've created this family that keeps breaking on me. And all I've done is delete all their dimensions, redimension it, reapply the exact same parameters, and the family starts working for them. So paying attention to the order of operations for placing your dimensions, placing those dimensions on those reference planes can also become a very big deal when you're looking at it. Excuse me. So one of the other things about reference planes that not everybody knows, we talked about the defines origin. So if you create a family like, man, I didn't want that center reference plane to be the origin, you can grab another reference plane and check it, and you've switched that constraint now. So now this one is no longer setting up to define my origin. This one over here is now my origin defining space. That's cool. I have done this in some families in the past for clients. And then by doing that, it's broken the family again, because then this dimension string might not have been set up in the order of operations it should have been. So paying attention to that and start coming into understanding that can be one of those things. Now, another little known value about reference planes you get inside of here is wall closure. So this wall closure checkbox will allow you to then tell Revit wraps where they need to return to. So in this family, it's completely pointless. It's not going in. It doesn't have an opening. But if I come back to this one, if I come back to this value, one of these ones inside of here I have, it's just the one in 3D. If I come back to this one here and I start looking at it and I go to the floor plan, you're going to see that in my door family, I actually have the brick and I told it to wrap around, right? So in that family, I told it to wrap. And the reason why this is going here and not just to the center line of the family, of the wall, excuse me, is in my family, I happen to have a parameter in there called wall closure. And what is that finished setback? So I've got a material return on the push side of my door. If I go make this like 9 inches, I'm going to be able to tell that brick to wrap all the way down to 9 inches, right? And anything else in that wall that has that wrap value. That's what that wall closure checkbox gives you. So it's got to be a wall hosted family. That family has to have an opening, not just a void. And then that wall closure will take into consideration for you. So that's the other thing on reference planes, kind of make these start doing what you want them to do and be able to come in and really look at what you're looking for. Okay, cool. So the other thing I always like to talk about on families getting inside of there is now we start talking about this. The one thing that I start getting into is when we're dealing with arcs or circles, how do we constrain an arc or a circle? How do we make those arcs do what we want them to do? In this case, I'm just going to go do a model line, could be a symbolic line, whatever. And I literally just want to go through and do an arc. So in Revit, anything you're drawing that is a curve that's non-straight will give you the option to say, let me display that center mark. When I display that center mark, I can now see where the center of this object is. So if you wanted to try to constrain this curve to a center point, this is how you need to do it by turning that center mark on. You can do that for anything in Revit. If you draw a curved beam, a curved wall, a curved line in a sketch, and inside the project environment, all of those are going to have the value for center mark visible. The other thing that you see, and this is the only way I know of to do this, is it'll give you an arc length that's an angle. So it's the angle arc length, not the actual arc length dimension command. So in a family environment, I always hear people say, man, I struggle with my door swings. If I change that door swing to be greater than 180, it does some sort of weird flip for me, right? I get the same thing with, oh, I've got these clearance families, whatever we're going to start doing in that. So when I get in here and really start looking at that, I can come in and just tell Revit to give me this angular dimension, right? If I delete that, I have not ever found a way to go into Revit and say, cool, let me go to my angular dimension and grab these endpoints to dimension that angle. I've never been able to do that in Revit. Somebody might have a way. I haven't found it. So by clicking this, I now have this angular dimension. So if I were to come up here and just add a parameter for this, I now can be like, cool, I want that angle to be 45 degrees, 55 degrees, whatever. And I'm controlling the length of this just by changing that angular value. I don't need a reference line. I don't need a reference plane. I'm doing this, right? Now, as we've all been into families and we're start looking at this as well, right? As I'm doing this, I don't know if you notice, it's been moving all over the place. So again, I would want to constrain that to the center of this family. So as long as I have the center mark visible, I can use those check boxes to start coming in and telling this, cool, stay constrained to that location. So now if I come in here and start changing those values around, it's going to be like, great, I'm doing what I'm supposed to be doing. But if I want to do something like a door swing where I want you to be controlled from this point, I'm going to need to control one of those ends, wherever that might be. So if I just take this currently and I rotate this around, I'm going to place the base point here in the event it's not. I'm going to grab its end point and rotate it around. Now that I've done that, I can align and lock the end point of that curve. And by aligning and locking the endpoint of that curve, now when I come in here and change this angle to be like 77 degrees, cool, you're noticing it's going to be going one direction or the other. Also, you're going to notice that if I start coming here and making those values greater, this is constrained. I'm doing the angle wrapping around. I am never going to have this family flip. So as I go through and do this, this is how I've always done my doors. I've never had a door break at a 180-degree angle, or in this case, a 230-degree angle. My doors are always going to go ahead and be fine with whatever value I decide to put inside of there. So this is one of those things too, that angular constraint, constraining a beginning point. Now, the other thing is in Revit, we've all had these families where they're working great today, then in 6 months, or we upgrade the family to a new version, all of a sudden something starts breaking. You're like, man, I constrained everything. I thought, what's going on with this? In your visibility graphics, under the annotation category, dimensions have this be for the project environment as well, but dimensions have this value for automatic sketch dimensions. If I turn this on, you're going to start seeing that Revit's like, cool, I'm going to display these automatic sketch dimensions. And what this actually means is this is showing you what Revit is not constraining, but associating things to. So the endpoint of this line is associated to this reference plane. So if I take this reference plane and move it, that is going to change that line. So my line is moving because it's being like, hey, I've got a reference to be to this reference plane, right? That's where I need to go. If this reference plane happened to be like right here, and maybe I move this to here, and then I come back at some point in time, it might decide, oh, cool, I'm going to change my reference to that. So now if I do this and I move that same reference plane I was moving before, notice this line is not moving. I've changed the Revit internal associativity manually to be to a different reference plane. And you're like, but when this was moving, that was moving with it, and now it's not. I manually did this, but Revit sometimes will start automatically doing this for you, especially if it's something like, oh, cool, I put that on top of that, and then I moved it. One day Revit might be like, oh, I'm going to reassociate myself to that other object. So turning on the automatic sketch dimensions in your families to start to see, do I have any of these blue dimensions? If I do, I haven't constrained this family properly, at least in my opinion, you haven't, because Revit's got this automatic associativity built into it. I don't know what that's associated to, right? I'm like, oh, cool, this should have been over here. And now my whole arc is like, where did it go? Oh, now it's over here doing something weird. So when I start looking at this, almost all of my families, and even definitely in my family templates, I have turned on the automatic sketch dimension. So as you start drawing, you will see these blue dimensions pop up, letting you know you need to do something else. Like in this case, cool, that's constrained there, but really maybe I wanted a radial dimension. And if I do this and I add a parameter for this, I'm just going to call it R. I've now got a radial dimension. Notice how that dimension, that automatic sketch dimension disappeared. So now if I move this reference plane, it doesn't affect that. If I move this reference plane, it doesn't affect that. It is staying where it is because I have now constrained this element. So when you start getting into families, turn that automatic sketch dimensions on, turn them on and off to really start seeing, because that's truly why I find most often families start to break, is you start turning that on, like, oh, wow, look what it's doing. The other thing about that too is you might start seeing a whole lot of blue automatic sketch dimensions. I'm just going to come back and draw another model line. I'll just draw one like here just to see. So you'll see that not only am I getting a dimension from here, the start point is giving me a dimension, an end point is giving me a dimension. And actually this end point isn't even going to the reference plane, it's now going to the arc. So if I were to change the angle on this line here, this line could possibly move, or if I move this line, something else could happen. So that can start happening. Same as later on for those CAD users out there. So for me, when you start seeing these dimensions, sometimes you're like, cool, but I don't really know what this was trying to auto constrain to. If you right click on a padlock in Revit, does anybody know you can say show related? And when you do that, it's going to say, cool, I'm going from this model line. And if I switch it to the endpoint of this model line, it's going to highlight those elements you're going to. So if I did this one down here and right clicked on the padlock and said show relate, it's like, cool, you're going from the model line you drew. Oh, it's also going to the reference plane, center, left, right. So that padlock will show you what's going on as you go through as well. So as you're getting into this stuff, it lets you know, oh, maybe I should have constrained that line's endpoint to here. The second I do, that one dimension went away. Oh, maybe I did want to constrain this lines to here or whatever. I needed to align and lock this to this reference plane. The second I do that, that automatic sketch dimension goes away. So as you start manipulating and getting into your family, start constraining it. If you never see a blue dimension, that is a good thing. You will also see you can get those inside of the extrusion. Oops, I did that one in an elevation. So let me go back to that right elevation. If you edit an extrusion, you're also going to see, if I go into VG and turn on my automatic sketch dimensions in this view, you're going to see that even those sketch lines get those associativities to them. So again, they're not constraints, they're associativities because they can change their associate as they see or deem necessary. So if you're really getting into this, even in sketch mode, you will see this. That's one of the best ways to start going through and playing with what's going on those visibility or the stability for those families when you get into it. Oh, I lost some screen stuff here. So I got to move some things around again. I'm not with my second normal monitor. I only have a tiny second monitor and I'm trying to see everything, make sure I'm covering what I wanted to cover. So as we start talking about those same scenarios of these are the reference planes, these are the constraints, how to do is the other thing I touched base on was directionality getting into this stuff. So let me cancel that. I don't need to be, yes, disregard. So as we start talking about that stuff, and I showed it a little bit inside the family there with, and close this one. I don't need that one open anymore. Inside of here, really understanding, okay, reference planes have a directionality. Those are easy to understand, but reference lines, sketch lines, and everything you deal with in Revit can have a directionality to them. So like I said here, these ones all have the ground plane as the same direction, but that's why the clock in this space, hey, that's going vertical or whatever it's doing, that's all the same. But now I'm looking at these cubes here. Why did these cubes all come in with things being into different crazy scenarios? Well, if I go edit this family and start looking at this family, I went in and started drawing a whole lot of extrusions different directions. So this one, I drew an extrusion using the rectangle command. I went from the upper right left corner to the lower left corner. I did an extrusion here going from the top left to the bottom right. I did an extrusion here where I drew lines manually. And I went through and started drawing all sorts of different scenarios so then I could understand when I'm back into that project, okay, this one was drawn with a rectangle going from here to here. It pointed to the right. Okay, that makes sense. It's, you know, above the second pick. But this one I went from right to left and it did the bottom down here. So I never really could remember which directionality was giving me which sort of scenario. But you can see it's literally one extrusion, or they're all different extrusions, but all those sketch lines were drawn different directions. So knowing and understanding everything in Revit has directionality to it. Part of the reason why I also show this is that first family I created, I've actually had families where I've had a material to them, like my TV, and every time I applied the material to my TV, that material image came in backwards. It was mirrored. I'm like, why is my TV image always mirrored? The text is always backwards. What's going on? So I went back and looked at my family, and what I had realized is that extrusion had a negative value in it. So rather than that extrusion having a positive value here, somebody had like said, oh, cool, I wanted to associate it to, let me give this a name. We'll call this one test. I'm going to grab this extrusion. I'm going to change its work plane. and I'm going to edit that work plane to go to that test scenario. Like, cool. So now it went that way, but like I really needed to constrain it to the outside. So somebody just came in and aligned and locked it like we would do. And then I realized that that extrusion, again, had a negative value. That negative value was putting the image I had on backwards. I have not tested this in a few years, but just understanding that I kept doing it like, man, so I would go into like Photoshop and I'd mirror my image and bring that mirrored image back in as my rendering image. And I kept having to do that every time I did a TV. And I'm like, this is ridiculous. There's got to be something better. That's when I started realizing that even the directionality doesn't only affect the placement of families, but it could possibly affect the rendering image that comes in. I believe this has been fixed in the recent years because when I originally created this crazy little file here, my rendered images would come in different directions. As I've upgraded this, it looks like the rendered images all come in the same, but it was kind of bizarre to me because I had this family is like, I did this and this same material, sometimes it'd be rendered this direction and that direction. I was like, why is my grain material rendering differently? So that can become one of those scenarios of, oh, when you look at this, the directionality used to matter for materials, but I don't think it does anymore. Okay, so just understanding the directionality of your families for that can happen too. The other thing on that could be is like, what if I wanted to rotate this? What if I'm like, cool, but on the sides of this, when I brought the material in, I don't want to have to associate a new material in Revit with a 90-degree material, right? I've got wood grain 90, wood grain 0. I don't want to have separate materials with separate images to start getting that into play. So when you're in the family environment, I often will have a material I call, I have one called directional display. I don't think it's actually in this family, so I'm going to go ahead and open up a different family real quick. I have a material that I call directional display, and I literally go through into this family, and I have a hatch pattern on it. The only reason I have this is here so I can start coming in and say, cool, what if I wanted these hatch patterns to all rotate, or what if I wanted them at a 45, or whatever you wanted to do there? Within the family environment, you can tab select and grab that hatch pattern. And if you go ahead and rotate that hatch pattern, that's not only going to be rotating any hatch pattern you put inside of there, it's going to come in and say, cool, that's where my rendering image is going to go. That's the directionality of my rendered images. So like for me, and I know it sounds crazy, but like all my door families, if I have stiles and rails, I don't do those as a single extrusion. My door families, the stiles and rails are all modeled as individual extrusions. So therefore I can have control over how I want to rotate these materials. I even go so much as it's the edges. I rotate the material on the edges, the top, the bottom, etc. Because as we all know, within Revit, the only hatch patterns you can manipulate within the project are those ones assigned to layered system materials. So if you're like, cool, I wanted this to rotate in, I'm gonna go ahead and load this into my project. I'll load it into family stability, RVT, that one. We'll place this here. We'll go back to the 3D view and we will look at that family I just placed. So you can kind of see that, okay, cool, I don't even know what material's on here right now. Acoustical ceiling, that's beautiful. I didn't want that button. That is a beautiful thing. Let's go switch it to be one of the woods that I'm already using. It's probably wood stained. We'll see. If not, we'll switch out. Right. So now we can see that, okay, this material is going horizontal. This material isn't going vertical. So again, kind of the same scenario. When we start looking at this, if I go back to that family, like, cool, but I didn't want this one to be vertical. And you can see the hatch patterns here, or maybe I didn't want this one to be vertical. I can grab this. I can use my rotate. I can go ahead and rotate that 90 degrees. And now it's going to be rotated. And if I'm really OCD and I want this stuff, which I am, and I want it all to line up, I could then be like, cool, the base of this family is the ground. So I always want that to be at the ground. And I could even go into an elevation and do like an equal dimension string. Already did that in the plan. So I'm going to use that one to line it up. So same scenario here. I'm going to grab the bottom alignment and align my hatch pattern to that. And I'll grab the alignment up here and align this to this. And now when I reload that back into the project, you're going to see that that one little cornered rendered image, dang it, I hit the wrong button again. Load into project. Yes, overwrite it. Go to 3D. Now you can see my grain is going around and theoretically I have it all lined up. So really critical when you start getting anything like hatch patterns, tile materials, etc., or even in my case for wood. Like I said, if I were to go in and open one of my door leaves Grab a door leaf real quick. That would be in the L's. I know my alphabet. Which one would be the one? Oh, let's do a raised panel. So like even in a door like this, I've modeled each one of these as separate extrusions. I go through and I don't do them as one extrusion. They're all different extrusions. So I can rotate and move those elements around. So in this family, it's all different extrusions. I got a rail as an extrusion. I rotate each one. I don't even do like this style and this style is one extrusion. I do each one as individual. So then I can control those hatch patterns on each one of those independently. And it looks like a question did come up from Joshua. He said, how does the hatch pattern control the material pattern? Because when you're setting up those materials in Revit, it's aligning the hatch patterns to the material. So if I go into manage and I go to materials and I go to the wood stain material in the appearance tab and I click on I always forget where this is. If I click on I think it's the image here. No, it's the image, not the text. Stretch this open. You have, usually it's the link texture transformation. This is an old material, or is this a new one? No, this is a new one. It's old. But usually it's like the link texture transformation. So it's the kind of scenario when you start getting that, they do try to line up. Revit did fix that way back when. If you guys have been using Revit forever, it used to be you'd line up your ceiling hatch pattern and you get the ceiling hatch pattern where you wanted, then you'd render it and never be in the right location. So they did know that was a big issue. So you can start kind of come through there and get into looking at that as well. So hopefully that answered your question, Joshua. Okay, so that's kind of those things. So everything in Revit has a directionality, including reference lines, reference planes, right? So when we start using certain types of families, I'm gonna come back here. Which one is it? This one is it. So we start getting into here and using, okay, I'm going to use a reference line or a reference plane for this, or my sweep paths. I have sweep paths inside of this one. So I drew this one using this reference plane. I drew the path from the top to the bottom. I drew this one over here using this one. I drew the path from the top to the bottom. So these two are drawn the same way with reference planes drawn in the opposite directions. I then used a reference line to host of these objects, understanding I'm drawing this one from left to right and this one from right to left. So I did find with reference lines, if you were to take this and change it this way, did I get the reference line? Yes, I did. Where is its endpoint? There. I want to get the endpoint of it. Come on. Let me get that endpoint and move it. I'm moving the dimension currently. I want to get the endpoint of the reference line. Right? These didn't flip. So reference lines don't act the same as reference planes. There is just a positive side no matter how you draw it, which was kind of how you do it, which is kind of odd to me. So reference planes have positive and negative sides, but reference lines did not. So just do some experimenting, do some trying to figure out what's going on in there. See what you're literally going to be looking at as it comes into it. So it was very bizarre to me that, okay, this is what was going on. Now, the other thing when we start looking at this too to make your families consistent is if you're trying to associate something to like an angle, right? I'm sure a lot of us out there know that we draw reference lines as opposed to reference planes. So if I wanted to constrain something to an angle, I draw a reference line because a reference line has a start and a stop point. A reference plane technically doesn't. It's an indefinite plane that exists everywhere. So once I start doing that, I can align and lock the endpoints of a reference line to some reference planes. So now when I come in here and do an angular dimension and I constrain that angular dimension, oops, wrong button. When I constrain that angular dimension to something, this constraint is going to stay. So I'm like, cool, I wanted that to be, a 60-degree angle. It's going to stay and maintain this as opposed to rotating around some random point. I see a lot of people do that. But what's also cool about reference lines is they have a bunch of work planes. So if I come back at this reference line and I go look at this in my 3D view, that reference line, when I select it, you'll see it's got an X work plane, a Y work plane, and 2 endpoint work planes. So there's technically 4 work planes that you can start working on. So if I wanted to draw an extrusion, like a round extrusion on this or something, I can go ahead and say, cool, I want to set my work plane. I'm going to go ahead and pick a plane, and I could pick the endpoint of that. Now, if I were to come in here and we'll just do an extrusion, we'll draw it as a circle, we'll just say, cool, go right there and do this. What's great about this is that is now associated to that work plane. So it's telling me, ooh, my work plane is that reference line. If I were to come in here then and change my angle from 60 degrees to 45 or whatever I want to change it to, this is going along for the ride because it's constrained to that work plane. If I were to take and parameterize the length of this reference line, this is going to move with it as well because I associated it to the end of that reference plane. So, excuse me, reference line. So you do have the capability to go through and start doing some of that stuff when you get into it as well. So really another great scenario when you need things to be at an angle, especially if you're talking like detail components, you can associate your filled regions, your masking regions to a reference line. And as that reference line rotates, it goes along for the ride, and you can do it with a lot less constraints when you get into it. Same thing would be true for this, extrusion here. I could technically leave it at that. I could go constrain the length of this, and this is going to move automatically with the length of that, and it's also going to move with the rotation of that. So it can save you some of those that you're looking at when you get into as well. So the question came up, can you see the direction of a reference plane before attaching accessories to it? Good question. If yes and no. When Autodesk gave us the capability to see the name on the screen, the name by default is always going to be on the negative side of it, unless somebody mirrors it. Prior to me knowing what was going on with reference planes early on in my Revit days, I would like draw the reference planes I needed on this side, and then I would mirror all of them. And if I were to take this reference plane here, and I'm just going to go ahead and mirror it, I'm just going to mirror it over here to the side, right? So my name is still on the right. So looking at this in plan, I would sit here and think, cool, if I go set this up to be mirrored, if I were to go set this up to be this family and I make this a work plane, I'm going to expect that extrusion to go towards the middle. So again, if I go to my right side here and I go in and say, cool, let me go create, let me set the work plane to be the mirrored one. And I say, okay, and I go draw an extrusion on this guy. That's not the button I wanted. Sorry, I got some delay with my teams going on here. Go to a circle and we're going to draw this here and say finish. When I go back to the floor plan for that, you're going to see that that went the opposite direction. I'd be like, but that should be the negative value. So if somebody mirrored that reference plane, no, you do not. I personally, within the family editor, never mirror. I don't mirror extrusions. I don't mirror reference planes, anything, because I found that as you start mirroring things, again, this is one of those things that you could start causing inconsistencies in your families when you get into them. So I never mirror anything within a family. I'm not going to say never, but I almost never mirror anything within a family. Like if I need a new reference plane, I don't mirror it, I draw it. I'm also very OCD that I draw my reference plane so the positive side is always in, unless there's a specific reason I needed that to go out. So like when I drew this reference plane, I drew it from the bottom to the top. When I drew it on this side, I drew it from the top to the bottom. I always want my positive sides pointing in. I just know that's my consistency when doing it. And then once I'm done, I might be into a project, like I said, like those toilet partitions, they weren't working properly. So I had to come in and inverse these. I still didn't mirror it. I just inversed it by dragging the grip to get that to work. So I still didn't mirror the reference plane. I just drew it, inversed it upon itself. So that's kind of a thing. So yes, that was a great question as well. Okay, so yep, got that. Boom, boom, boom. Coming back. So reference lines do have all of those work planes. So again, kind of the same scenario. If I were to go do something else inside of here, so let me go create, let me go set, let me pick a plane, let me grab the horizontal plane there again. I'm just doing extrusions because they're down and dirty on this. But if I do an extrusion here and finish that as well, you're going to see again that if I go change that angle parameter on here to be whatever, it's going to rotate with it. Now, I'm not controlling where it is from the middle. I would probably want a reference plane, but that becomes something that you can really start getting into and looking at as well. And like I said, this can really start to play when we get into some of these other families inside of here. So when I start looking at my crazy 2D rebar family, there are a lot of reference lines or a lot of things inside of here because a lot of these are like, cool, I've got this reference line here. This is what's controlling my rotation. A lot of these then detailed filled regions are associated to those reference lines. So if this thing rotates, this is going to know it's supposed to rotate with it. So setting up reference lines, setting those reference lines as work planes, even in a 2D family, can really benefit you on what you're starting to go through and get into. We had 1 minute left, and there was one question that I did not answer during. So, a good question did come up saying some families cannot be placed into a project after version upgrades. Great, they work fine in 29, but not 22. How do you know what's wrong? Unfortunately, usually you can just upgrade the family without loading it into the project. And then if you open that family and start flexing it, playing with some of those values when you get into it, and be like, oh, let me play with some numbers in here. Hit one, change it, see what's going on. You know, what if I change this to be 135, hit the apply. Usually when it's broken in the project, if it's broken in the project, it will also be broken within the family editor as well, unless there happens to be several types. And sometimes when you load a family from one project to another project, if you have a type that has a broken value in it, it's not going to display that when you open up the family. It's not going to display it when you hit apply. It's only going to work if you change it to a family. So if I had a family here, I was like, oh, I needed one of these to be a 0 length or something. Revit's going to be like, yeah, I can't create this one instance. So the other solution is open that family, delete all the types, then just try loading it into your project and see if there's something in one of those family types that ended up being broken. So hopefully that answers that question as well. Da-da-da. Yep, I answered that one. So I am 1 minute over, so we'll try to grade through the last two here. If you have a trapezoid window family and wanted to look the angle side of a specific angle when someone changes the width of it, yes. So you can start saying, hey, I'm going to change the angle if you change the width. Absolutely, I'd be locking those things to a reference line. So kind of like here, if the length changes here, I need this. This is still associated to that reference line. If the length changes, this is constrained to that. So yes, it can do that. Now, if you're in a 3D world and it's all one extrusion, you obviously can't make the whole extrusion associated to that reference line or make that your work plane. So yes, you're just going to be doing aligning and locking on those constraints. And the last question, once upon a time, I had to create a family with 2 braces that rotated around a center strut. Had variable angles, they would come from the center strut. Sorry, I need to move this question up higher. I can't read it on my small screen. I had to create 3 levels nesting to make it happen when loaded into. One for the angle for the strut, another for the rotation, yes. So if you're going to have something where I like, oh, I want this to rotate left and right and in plan, sure, you might need to nest a family that rotates 1 degree, then load that family, nest that family into another reference line that changes the rotation. So like I could have a pipe that not only tips in and out, but rotates around as well. Yeah, and certain things like that, you're going to need to go through and get into several nests inside of there. So I'm 2 minutes over.
Oh, actually, you are not. You have until the top of the hour. So
I thought we only had 45 minutes.
That was to give you time for Q&A after.
No, see, I never understand that.
But no worries, Brian. I actually have one more that came through on the chat system. How to standardize a family which was created and can be converted into IFC format.
How to standardize a family which I created so it can be converted into an IFC format?
Well, and they wrote and can be converted into IFC format.
Well, unfortunately, in the Revit world, we can't export families directly to IFC, at least not to my knowledge. And I will be the first to admit I don't do a whole lot with IFC. But I don't believe there's any like export this family to IFC natively. You can export the project to IFC. That's not a family. Let me find a family. Sure, my very highly complicated family we just created. I don't believe you can export, I could be wrong, to IFC. Yeah, IFC is grayed out. So you'd have to load that into a project and then export it out from a project. If you only wanted the one family, you could load that out, export out as a single element for IFC importing as well. But yeah, we don't have that capability out of the box Revit to just take a family straight to IFC. Standardizing that family, I don't know necessarily what you mean. It can be like, hey, I always need this to go out to that and that to go out to that. That would be one of those things that you want like this part to go out to this IFC category and that part to go out to that IFC category. If that was the case, you would have to nest your families, and those I'm assuming would have to be shared nested families. And I think I closed my door family earlier. So one of the examples of that would be like my door family, where if I look at any of my door families, we'll get my door single. It's probably got a BAT. It's probably been moved because I literally just opened it and saved it. Go back here, go to DRs. Sure, we'll go to door double. That'll work too. So when we start looking at the double door family here, if I wanted the leaf to go out something as different as the frame, so this leaf is a family, right? That family, when I get into it, is a nested family. But this is nested and shared. That becomes a key part so it'd go through. I go back to the other part of it, the frame, if you wanted that to go out as a separate IFC family, again, that frame family I get into it is a nested family, but that nested family is also then shared. So that way, when you export out to IFC, all of those are going to go out to different IFC categories once you set up the mapping for those. And again, within the Revit project environment, these are all set up as doors, but I also, I actually don't know if I know the answer to that question. I was going to say these are set up as doors, but they're on a subcategory of frame mullion. So I think that's how you would have to get that to go out as well. So make sure you're also assigning subcategories within Revit so you could map those subcategories out to IFC as well. So that would be, I'm guessing, the standardized portion of that Q&A that you just asked.
Yeah, and we have one more super easy one actually. Can most of these reference planes and lines directionality be embedded onto a Revit or onto a family template?
That was the one thing I didn't cover, but I do talk about in the handout if you go download it. So I was in my crazy family here using my template. Directionality cannot be, but the is reference. So like when you go start out of the box and draw a new one, you go to reference plane and you go to start drawing that reference plane, the default is not a reference, or is a weak reference. My default becomes not a reference. And so for me, what I did in my project is I went in and I opened an RFA family. I went in, I drew a reference plane, I changed it to not a reference before I drew it, and then I deleted it. Then I've changed a whole bunch of things. Like I can't stand the giant dimension arrowheads. I can't stand that the dimensions don't snap to each other. So I changed a whole bunch of things in my family that was an RFA. And then in Revit, if you just rename that an RFT, and I'm going to make a correction here. I tried doing this the other day in Revit 24 and 25, and they broke that. So I'm not sure if it's going to work. I've got to actually get with some of the Autodesk people. But it used to be the fact that you could just rename that RFA to an RFT, and now you have a Revit family template. Go start a new family from that. My old RFTs, I could still rename and go back and forth, but I tried doing the out-of-the-box Autodesk one like a month ago with Paul Aubin and I were playing with this one, and we were not able to. We asked Aaron Malik, he was not able to either. So something happened, and I need to get with Autodesk to figure out what that is. But if you wanted an old family template that has some of that in there, just email me, join us on Revit Radio. One of those things, I will send you my family template, which has some of those things set in there. That will also let you rename it to RFA, RFT, and back and forth.
I wasn't aware that limitation was there. That's good to know. Thank you.
It was there in old versions of Revit, and then they fixed it, and then I think it came back. I went in 23 and tried it, I believe, as well, and it also did not let me do it. My family templates still work, but if you use a new family template, it's broken. So I don't know what that is. So,
and I might not be running into it because I'm the same as you and have an older set of family templates. Another question came in while you were covering that one. I know currently there is no way to downgrade a Revit family to previous versions. They're saying from 24 to 22. What would be the best workaround?
There's a lot of workarounds. Unfortunately, you're going to lose any constraints you have associated to that. So if it's a parametric family, it's gone. But there are ways to go out to IFC and bring the IFC into Revit. There's ways that people are using like Rhino inside Revit to do things like that. There's a lot of different workarounds to do that. It looks like somebody actually even put it in chat. So thank you for that, Samuel. But the problem with all this is if it's a parametric family, you lost it. It's done. Mm-hmm. So there is no way to take a parametric family back. It was just something you had for geometry purposes. Yes, you can do the IFC in and out and back and forth. I've seen some people do it as a DWG, as long as the DWG is okay. A lot of different workflows in that, but you will lose all parameters or all associativity to that, including the fact that, oh, gee, this might have been on a subcategory. I didn't talk about the visibility that was set up, any of that stuff. It's all gone. Material parameters, all of that stuff, gone. So it gives you the geometry, but it doesn't give you a Revit family.
And somebody asked about the schedule of Revit Radio. So guys, I've already put a link in the chat about signing up for Brian's Revit Radio, and I will put it again at the end of this session so you guys can go and sign up for it.
And there's also the QR code for it right there.
Oh, perfect.